Okay, hello everyone, welcome back. So, yeah, we are done with questions 1 to 74 of Indices and Logarithm additional question bank in previous videos. So, in this video, we'll go from 75 onwards. Okay, as usual, a few rules. You should have solved these questions by yourself first, and then only you should come to the video, because only then that is useful. Second is, in this video, we are not going to focus on concepts too much, we are going to focus on tricks. That is, I am assuming that you have studied the chapters, and now we are going to see tricks on how to solve all the questions, or possibly all the questions, in 1 minute. Okay, fine. So we'll keep the lecture in simple English as usual. So let's start. 75. If log a by y minus z is equal to log b by this is equal to log c by this, then what is value of abc? Okay, one easy way to do this is assume everything as k. I've told you, whenever there are two equal to signs, generally assume everything as k and then rearrange. This is easy, but this is lengthy. Okay, a better way is assume some numbers. Now concentrate how to assume numbers. Let's assume xyz as something. Let's assume xyz as something. Just a second. Yeah, so let's say x is 1, y is 2, z is 3. That means this denominator y minus z is going to be what? Minus 1. Z minus x is going to be what? 2. And x minus y is going to be what? Minus 1. Now concentrate carefully what we have to do. We have to keep numerator same as denominator. We have to keep numerator same as denominator. Why? Because then we'll have minus 1 by minus 1, which is 1, is equal to 2 by 2, which is also 1, is equal to minus 1 by minus 1, which is also 1. So all three will be matching, right? That is our condition. This should be equal to this, should be equal to this. So let's try it out. Now log a is minus 1. Okay, first thinking about log b will be easier. Okay, log b, we want log b to be 2, right? Log of what is 2? Log of 100 is 2, right? That means b is 100. Similarly, we want log a to be minus 1. Log of what is minus 1? Log of what is minus 1? Or if you want, rearrange it. 10 raised to minus 1 is equal to a. 10 raised to minus 1 is what? 1 by 10. 1 by 10 is 0.1. That's it. Similarly, log c is also minus 1. Log c to base 10 is minus 1. That means 10 raised to minus 1 is c. Always remember the rearrangement. 10 raised to minus 1 is c. So c is equal to, again, 0.1. Now we want a into b into c. That's it. So 0.1 into 100 into 0.1. So that gives us 1. B is the correct answer, option B. Okay. For 75. Let's go to 76. Similar, let's solve in the same way. Understand, for logarithm, you must be familiar with rearrangement. That is, if you have this, something like this, you must be able to identify that you can get b raised to c is equal to a. This is the basic. This and basic properties of log and change of base formula. That's it. If you do these three things, then log chapter is very easy, and practice obviously. So if you feel that this chapter is difficult, I have uploaded the entire batch of logarithm separately on this channel. Entire batch of all chapters is available, but for log I have uploaded special 4 lectures which cover everything, so you can go through that. 76. Let's assume same things, x, y, z as 1, 2, 3. So denominator is also same, so it is going to be again minus 1, 2 and minus 1. Again ABC is going to be same, 0.1, 100 and 0.1. So we have a raised to y plus z. Okay, y plus z is 5, 1, 2, 3, right? So y plus z is 5. B is 100, 100 raised to z plus x is 4. And again C, 0.1 raised to x plus y is 3. Okay, and we can do this on calculator also. 100 raised to 4, 100 into equal to 3 times. Then into 0.1 into 0.1 into 0.1 3 times. Then again 5 times into 0.1 into 0.1 1. Again 1 is the correct answer, option B, option for question number 76. Okay. Once you substitute numbers, everything becomes easy, and that is possible for MCQ questions. So you must do it always. 77. Here it might be difficult to assume numbers, but let's see. If log a is equal to half log b is equal to 1/5 log c, then what is value of a raised to 4 b cube c raised to minus 3? Fine. Now, assuming numbers here might be difficult. Okay, might be difficult. I'm not saying it is not possible. Okay, just a second again. Yeah, so as I was saying, it might be difficult. So if you want, again, you can assume everything as k and then solve it. Okay, rearrange and solve. Because log a is 10, that means a is equal to 10 raised to k and so on. Or else what you can do is, let's put some numbers. Let's try so that everything is equal to 1. This is equal to 1, this is 1, this is 1. So 1 is equal to 1 is equal to 1. Okay. Now we have log a is equal to 1. That means a must be 10, right? Because log of 10 is 1. Then we have half log b is equal to 1. But if you know basic rules of logarithm, half log b is nothing but log of b raised to half. B raised to half is root b. So log of root b. Right. So we want log of, sorry, what happened? Log of root b is equal to 1. That means what? Root b is equal to 10. Right. Root b is equal to 10. That means b is equal to what? 10 square, which is 100. Fine. Again, similarly, we have log c into 1/5. That means log of c raised to 1/5 is equal to 1. That means again c raised to 1/5 must be equal to 10. So if we raise both sides by 5, then we'll have c raised to 1 is equal to 10 raised to 5. Right? Raise both sides by 5. So 5 will be cancelled here. C raised to 1 is equal to 10 raised to 5. So we have got three numbers. A is 10. Okay, let me write them separately somewhere. A is 10, B is 100, and C is 10 raised to 5. Right? 100 is what? 10 raised to 2. So let's write it like that only, because now they're asking A raised to 4, that is 10 raised to 4, into B raised to 3. But B is already what? 10 square. So 10 square raised to 3 will be what? 10 raised to 6. And C raised to minus 2, but C is already what? 10 raised to 5. So 5 into minus 2, which is, sorry, 10 raised to 5 into minus 2, which is minus 10, right? So if we add all the powers, because a raised to m into a raised to n is a raised to m plus n. So 4 plus 6 minus 10 is 0. 10 raised to 0 is 1. Option B is the correct answer. Okay. Similarly, 78th we can follow same approach exactly. Concentrate. We want everything to be 1. So again, follow simple logic. This should be 1. That means log of root a should be 1. Right? Half will go into power. So it will become log of a raised to half, or log of root a is equal to 1. That means root a is equal to 10. That means a is equal to 10 square. Okay, fine. Similarly for b, now if you observe the pattern, a is what? 10 square. Now b will be what? 10 cube, right? And c will be what? 10 raised to 5. That's it. Same, if you observe the pattern, c will be 10 raised to 5. So now let's put it. A raised to 4. A is what? 10 square. So 10 square raised to 4, that is 10 raised to 8. Minus b. B is 10 cube. C is 10 raised to 5. So 10 raised to 3 plus 5, again that is going to be 8 only. So 10 raised to 8 minus 10 raised to 8 is 0. So option A is the correct answer. Similarly 79. Now base is 2, but that does not matter to us. Still we can go by the exact same logic. Okay. Let's assume everything is 1 again. So now this 1/4 can go here, right? We want this to be 1. Concentrate. I'll explain logic for first one, then we can directly write last two. Log of a to the base 2, sorry, log of a raised to 1/4 to the base 2, we are assuming it as 1. Now if we rearrange, 2 raised to 1 is equal to this, right? That means a raised to 1/4 is equal to 2, correct? That means a raised to what? A is equal to what? 2 raised to 4. Because if we raise both sides by 4, a will be equal to 2 raised to 4. Now if you follow same pattern, b will be what? 2 raised to 6. C will be what? 2 raised to 24. Oh, or 2 raised to minus 24, right? Fine. So we have all the figures now. Let's put them in the answer. A cube. A is 2 raised to 4. So 2 raised to 4 bracket cube. That will be 2 raised to 12. Into b square. B is what? Let's check. B is 2 raised to 6. So 2 raised to 6 bracket square is 2 raised to 12. And C. C is what? 2 raised to minus 24. Okay. So that will be 1 upon 2 raised to 24. So if you observe, again everything is getting cancelled. Answer is 1. Option B. Same logic. 80. In 80, like I said, whenever there is different base, we should always make the base same. Always. So in 80, we can make the base same as what? First term will be 1 upon. It will be log AB to base A. That means it will be log AB upon log A. Or if we rearrange, it will be log A upon log AB. On the same lines, don't think about second term, just compare. Second term will be what? Log B upon log AB. Right? So denominator is common, we can add the numerator. log a plus b, log a plus log b. Log a plus log b is what? Log ab. Upon denominator is again log ab only. So again everything will get cancelled. Option B is the correct answer. 1. Fine. 81. Again there are different bases. If 1 upon log t to base a plus 1 upon log t something something, then what is value of z? Okay. Again, whenever there is different base, always change the base. Let's think about first term only. It will be 1 upon log t by log a. So that is if we rearrange log a by log t, right? So we are going to have, now observe, you don't even need to write in exam also. See, it will be what? Log a by log t plus log b by log t plus log c by log t is equal to log z by log t. Log t is common denominator. On both sides, log t is the denominator. So it will be cancelled, right? Because this side you can just add all three terms. Common denominator will be log t. Here also common denominator will be log t. So it will be cancelled. Fine. Now in numerators, what do you have? Log a plus log b plus log c, which is log abc. Fine. So you are going to have this log abc is equal to, on this side you have log z. That means if you cancel out the log sign, z is equal to abc, option A. Okay. Fine. 82. If L is equal to 1 plus log bc to base a, m is equal to 1 plus log ca to base b, n is equal to 1 plus log ab to base c, then what is value of this? Okay. Again, different base, so you can just change the base. I think this question we have already covered. I mean, similar question is there. If you observe question number 66, and compare the current question, if you observe, this is L, this is M, and this is N. Okay, that is what they have given directly, right? So sorry, the denominator, I think, I don't know, let me check. Oh, right. So not like this. If you observe, this is L, this is M, and this is N, right? That is what they have given in that question also, question number 82. So this, in question number 66, we got 1 by L plus 1 by M plus 1 by N as 1, right? And this is same question exactly. If you see, 1 by L plus 1 by M plus 1 by N is 1, 1 minus 1 is 0, option A. If you want, you can go to that video, but again, change of base you can try by yourself. 83. If A is b square is equal to c cube is equal to d raised to 4, then what is value of log abcd to base A? Okay. Now, again here, assuming numbers might be a good idea, might be, but solving it directly will be, I think, easier. But you can put numbers also if you want, if you put them logically. Fine. But let's solve. We want log abcd to base A, right? So let's bring everything in terms of A. How? We have A is equal to b square. That means root A is equal to b, right? If we take square root of both sides. So can I just write log of A is there, instead of b I'll write root A, because we just got b is equal to root A. Fine. Similarly, we have A is equal to c cube. That means if we raise both sides by 1 by 3, we'll have A raised to 1 by 3 is equal to c raised to 1. So c is what? A raised to 1/3. So can I just write A raised to 1/3? Similarly, same pattern, d will be what? A raised to 1/4. Okay. To the base A. That means here we have A raised to 1 into A raised to half into A raised to 1/3 into A raised to 1/4. We can add the powers. So it will be log of A to the power 1 plus half plus 1/3 plus 1/4 to the base A. You know that log of b raised to n is equal to nothing but n raised to log b. Right? I'm taking random letters. So we can just take that power outside. So it will be 1 plus half plus 1/3 plus 1/4 into log A to the base A. Log A to base A is always 1. That means answer is just this, 1 plus half plus 1/3 plus 1/4, option A. A is the correct answer. 84th is again a good question. The sum of this series is what? Log b to base A plus log b square to base A square plus log b cube to base A cube, and so on. Like I said, don't get confused. Always whenever you see different base, first thing is change of base. So always change of base, because base is not same. A square, A cube, right? So change of base. Let's do change of base. It will be, first term will be what? Log b upon log A. Right? Second term will be what? Log b square upon log A square. but I can take that 2 down, right? Because log b raised to 2 is equal to what? 2 log b. So can I just write this 2 here? Similarly, can I write this 2 here? Right. So 2 will be cancelled. It is again log b upon log a. If you observe, next term is also log b cube upon log a cube. Sorry, which is nothing but 3 will be taken out and cancelled. So log b upon log a. So we just have log b upon log a plus log b upon log a plus log b upon log a n times. So it is nothing but n times log b upon log a. That is not in the options because now we have to reverse the change of base process. We know that, understand, we know that log of b to the base a becomes this. So this can be written as this, n times log of b to the base a. That is option what? Log of b to the base a. Oh, good. They have taken this n also here because we have one more property of log. We can take that n in the power, so I can write that as log b to the base a, log b raised to n to the base a rather, right? So that is option A. Log b raised to n to the base a is nothing but n times log b to the base a. Fine. 85. 1 upon a raised to log a to base b has a value of. Okay. Now actually we have a property something like this, but the property is like this: a raised to log b to the base a, not a raised to log a to the base b. Okay. I feel they wanted to print something different, but let's try to put some numbers and solve. Okay. Because even by putting numbers you can get the answer. So let's say a is 100, b is 10. Okay. A is 100, b is 10. So this will be 1 upon 100 raised to log of 100 to the base 10. That is nothing but 1 upon 100 raised to 2. Because log 100 is 2. That is 1 upon 100 and 2 zeros, 10,000. That is not in the options anywhere if you see. A plus b is also not correct. So none will have to take, but I think they wanted to give something different. I don't know. Maybe they have made some printing mistake. We don't know. The options, there is some printing mistake in options also, right? So whatever. Next. 86. Value of this expression is what? Again, base is different. So first thing, change of base. Let's do change of base. A raised to, it will be log b by log a into log c by log b into log d by log c into log t by log d. You can see these terms are going to get cancelled. It will only be a raised to log t by log a. That is nothing but if we reverse the change of base process, it will become a raised to log of t to the base a. Now we have that property, a raised to log of b to the base a is nothing but b, right? So t is the correct answer, which is option A. You should know the basic properties, then the chapter is not really that difficult. Okay. 87. For any three consecutive integers x, y, z, this equation is true, false, sometimes true, or cannot be determined in case of variables with cyclic order. Fine. So first of all, if true, false is there, then this option may not be that logical, right? Fine. Now we cannot put numbers. Why we cannot put numbers? Because we have to check if it is sometimes true or always true. So let's check by actually solving it. We know that x, y, z are consecutive integers. Consecutive means what? Y minus 1 is x and y plus 1 is z. So can I just write y minus 1, y and y plus 1. Okay, x, y, z. So now let's put it here. We want log of 1 plus x. X is what? This. Into z. Z is what? This. Minus 2 times log of y. Fine. This will be log of 1 plus. Now what is a minus b, a plus b? A plus b, a minus b is a square minus b square. Minus 2 log y, or 2 log y, can I write it as log of y square? Right. Okay. Now 1 and 1 square can be cancelled, both are 1. So log of y square minus log of y square. Log y square minus log y square will always be 0, right? So this is 0 is always true. Option A is the correct answer. Okay, not sometimes true. Fine. 88. Okay, 88, 89, 90 are good questions. Fine. So maybe this is now nearly 20 minutes. So what we can do is, let's pause here for this video, and in last video I'll cover next 10 questions. Okay, that will be a short video, 10-15 minutes. In that we'll cover the last 10 questions of this additional question bank, and then it will be over. If you have any doubt, you can let me know in comments, and you can join the Telegram channel which is in the descriptions, so that you get more information about next sessions also, and you get daily MCQs, because I post MCQs there which are different from those in the module. They are not in module, you will not find them anywhere. So those are new MCQs, so I put them. There is a discussion group also where you can ask doubts. So yeah, fine, let's stop here for this video. We'll meet in next one. Bye everyone.